When you're solving what's called a literal equation, what you're really doing is just rearranging a formula to solve for a specific variable. So in this first example, on the left, we could have a 5x or 5y, so we could solve for y, or we could solve for the x on the 12x. Our directions say solve the equation for y. So if we're going to solve for y, our y is in this term, which means this is what we want to get by itself. So if we're going to isolate the 5y, we need to move the 12x to the other side. So since it was a plus 12x, we're going to subtract 12x from both sides. That leaves us the 5y on this side that was in the box. These cancel out. And on the right side, these are not like terms, which means we can't combine them. So we're just going to list the two terms together. So negative 12x, and it was a positive 9, so plus 9. And then to get just the y, we need to divide by 5. We're going to divide everything on the right-hand side by 5. So these 5's cancel out. So we have a y equals. And we're going to, it's kind of like a division distributive property. We're going to divide each one of the pieces by 5. So negative 12x over 5, we're just going to leave as a fraction, negative 12x over, or negative 12 over 5 with the x, and then we're going to do the same thing here, so plus 9 over 5. We've got some fractions in there, and that's fine. Fractions are okay. So our final answer, y equals negative 12/5 x plus 9/5. All right, then it says to plug in our 2 and see what we get. So if we plug in 2 for x, and we're going to change this, we're going to plug in 5 for x. So just so we don't end up with quite so many fractions to it. All right, if we plug in, let's go ahead and use the 2 that we had originally. All right, so if we plug in the 2, we have negative 12 over 5 times 2 plus 9 over 5. So our negative 12 over 5, or times 2, gives me negative 24 over 5 plus 9 over 5. If I add those numerators, negative 24 plus 9 would be negative 15 over 5, which is negative 3. So I guess we were okay with that fraction in there. All right, let's do a second example. So the same thing, we're supposed to solve for y. So here is our y term. So to move the 3x from the left, to get the 4y by itself, we're going to subtract 3x from both sides. So this 4y just comes down. And on the right side, we have negative 3x plus 16. And again, we're not allowed to combine those two terms because the first term has an x. The second term is just a constant. So they're not like terms, so we can't combine them. Then to finish up, we need to divide everything by 4. So the 4's over here cancel out. We have y. We're going to pretzel, what I call a pretzel because I think it looks like a pretzel when we do it. We have negative 3/4 x. Then we have to do the same thing here. So plus 4. Then we're supposed to take an x value of 1 and plug it in and see what we get. So our y is going to equal negative 3/4 times 1 plus 4. So negative 3/4 times 1 is negative 3/4 plus 4. So if we use an x of 1, we get a y of negative 3/4 plus 4 makes 3 1/4. This one does end up with a fraction, but that's okay. Alright, the other way we can use these is to actually rearrange a formula. The reason you want to do this is if we actually know the area we want, for instance, we already know A and we're finding one of these other variables, either base 1, base 2, or height, we don't want to have to keep rearranging it over and over. So we're going to actually rearrange the formula so that we can see, or we can solve for the H. Okay, so to get the H by itself, that's here. We have to get rid of all the other pieces. So let's start with this fraction, a half. So to get rid of a half, we need to multiply by the reciprocal. So we're going to multiply this side by 2. If we multiply the right by 2, we have to multiply the left by 2. So 2a, and then over here, those cancel out. So we have our parentheses, b1, base 1, plus base 2, times the height. Alright, now we have to get the h by itself. So it's attached to the base 1 plus base 2 times the height. So to move it, we're going to divide both sides by that set of parentheses. Alright, so parentheses here cancel out. So on the right side, we have an h. And on the left side, we have a 2a over b1 plus b2. So it looks a little strange. We just have to kind of think of if they were numbers, how would we get that piece by itself? So we're using opposite operations each time. Alright, so this time we're supposed to solve for c. So here's my c. It's part of this whole piece right here. So to get that piece that's in the box by itself, we need to get rid of the plus 32. So we would subtract 32. The opposite of plus 32 is minus 32. So we have our degrees Fahrenheit minus 32. We can't combine those because they're not like terms. Equals 9/5 c. Alright, now we have 9/5 times c. So to get rid of that, we are going to divide by 9/5. If you divide by a fraction, that's the same thing as multiplying by the reciprocal. So if we multiply the right by 5/9, because 5/9 is a reciprocal of 9/5, we have to do the same thing over here, but in order to do that, we're going to have to put that in parentheses. That makes these two cancel out. So we have 5/9, and then in parentheses f minus 32 equals c. So if we knew our degrees Fahrenheit, we would plug it in the parentheses, we would subtract 32, and then we would multiply by the fraction 5/9. Alright, let's do one more. So this time we're solving for h. So h is in this piece here. So that means we need to get rid of this 2b, positive 2b. So we're going to subtract 2b from both sides. So on the left we have p minus 2b. We can't combine those because they're not like terms. And on the right we have 2h. To get just h, we need to divide everything by 2. So over here, the 2's cancel out, so we just have the h. And if we do our pretzel, that would give me 1/2 times the perimeter. And if we go this way, those 2's are going to cancel out, so it would just be minus b. So 1/2 times the perimeter minus the base. If we did this same formula, only this time we're solving for b, it would be similar to that, but just a little bit different. So our b is in this piece, so we would need to start by subtracting the 2h. Again, we don't have like terms on this side, so we're going to have to subtract our 2h. And then our last step is going to be to divide everything by 2. So they cancel out here. We're going to have to do the pretzel. So p over 2 is the same thing as 1/2 p, because this is really 1p over 2, minus And then negative 2 over the 2 becomes a minus 1h. And on the right we just have left the b.